Yo, welcome back to the NucleoGenesis project. My name is Dr. James Utley. I am your resident codebreaker data scraper, and we are on part three. So, part three of the NucleoGenesis project. So, what is nucleogenesis? Okay, real quick. Nucleogenesis is a temporal framework for eukaryotic nuclear blueprint, archive, and reconstruction. So, we've been going over this, and it's basically taking the information from a fresh sample as well as some samples from a dried blood spot, and then being able to develop a nuclear blueprint manifest or a digital file of a nucleus that then could be given to synthetic biologists in the future to reconstruct the nucleus. So the reason why this is done is it has the ability to survive long lengths of time, which means like a robust mechanism for calamity. That's a fire destruction of everything, as well as it has the ability to have preservation that can travel deep space, and that's the idea. Okay, so we left off yesterday at 1.4, which is the information theoretic framework for temporal nuclear reconstruction. Again, it's a mouthful, but really what it is we have two samples. We have our fresh sample, which collected at T0, which is denoted by D here, and then we have DBS at T0. So we have the collection of the sample, and then the analysis, fresh sample, and then we have the analysis that is part of the dried blood spot or that collection method, right? So it denotes that data sets are required. So the D stands for data set, are required at the time of the biological collection from the fresh cell and the dried blood spot fractions. Remember, there's two. So there's two fractions respectively. These data sets capture complementary classes of nuclear information as defined by their physical survivability and entropy. So the ability for it to survive over time and degradation, as well as the entropy. And that's high. That's categorized by high and low entropy. Okay, at the later reconstruction time, or TR, the total information substrate available for the nuclear reconstruction is given by here. So this is a loose math proof of how this works, right? So we have this variable called the DBS reanalysis, so the data from the DBS reanalysis, and that denotes additional information extracted from the archival dry blood spot using analytical technology, sequencing platforms, and computational methods that become available in the future, available at times that's past the collection time, the initial collection time. Importantly, the underlying biological material remains unchanged. Only the resolution and interpretability of the recovered information increases. So you have an anchor, which is anchor information, which is from the fresh sample collection and testing, and then you have an initial baseline from the dried blood spot initial testing, and then so that keeps the anchor. Now, as technology improves, then you can go ahead and go back and hit another dried blood spot sample, and then you can add layers onto your framework here, right? So now it's an informational monotonicity under archival integrity. All right, so this means that monotonicity reflects a fundamental asymmetry between information loss and information recovery. While high entropy, structure dependent nuclear features can only be captured at the T0 mark, or the time of collection, low entropy, chemically persistent features archived in the dried blood spot form a permanent information substrate. Advances in the extraction of chemistry, sequence fidelity, and computational inference can refine or expand recoverable information, but cannot degrade the information that's already preserved. So the information block that you have made, that is your anchor, that is from the time of collection fresh sample information, as well as time of collection dried blood spot, low entropy, biophysically stable information, that builds your anchor block. Now, with that anchor block, then you're only adding information to start filling in the gaps. And why you do that is to try to provide the most complete picture, and will be ever evolving. It's the nuclear blueprint manifest, which will be a digital twin of a nucleus, and then it'll have enough information that a synthetic biologist could then reproduce it in the future. Right? That's the high order explanation. Now, okay, but consequently, early archival of the dried blood spot material is strictly advantageous. The archive function as a time invariant information anchor, which I explained, which allows for progressively richer reconstructions may be built, transforming nuclear reconstruction from a single irreversible event into a cumulative technology agnostic process. So you're building your information anchor, and then that's what we know at this time. And then as technologies improve or information improves, and you're just adding it on top of that. All right. Now, this graphic right here is kind of a good overview here. which you have, as I mentioned, the dry blood spot archive, your fresh sample, and your recovery status. So we have our DNA sequence over all three methods, preserved and with high integrity. Now we have the methylation layer, which is preserved, and pretty stable, and that's all. Now we have the chromatin contacts, right? So it's preserved, lost, not recoverable, and we know that. Accessibility, right? Preserved, lost, degraded, right? And histone marks, preserved, lost, and absent. And that is a really good preservation and recovery matrix, and it compares the molecular feature integrity between the fresh sample and the long-term dry blood spot archive, and it highlights what genomic and epigenomic signals are recoverable. And that's the basic framework goal. Now tomorrow we'll go into the dual stream sample acquisition and management, which is how do we get the samples, how do we conduct a QC and things like that that will be able to ensure that it formalizes the event, which is the T0 mark. So therefore we can have predictive analytics for the future. All right, well, with that said, again, my name is Dr. James Utley, and if you want to check out the NucleoGenesis project, go to my website, syndicate-labs.io, syndicate-labs.io. It should be highlighted in the caption there. I'll say it one more time, syndicate-labs.io. And yeah, I'll see you in the future. Peace.